Hi guys, in today's coding challenge we're going to be making some lightning strikes. So there you can see when we click the screen we get some nice pretty lightning strikes. So I'll show you how to do it. Let's go. Okay, so I've got the standard setup here, just the setup and draw function Blake processing script. So let's get into it. We're going to be creating some lightning. So to do that, firstly I'm just going to set the size of the canvas to be 1080 by 720. And then what I'm going to do is I'm going to create a new class called like strike, because it's a lightning strike, so we'll call it class strike like this. And so we need to create a constructor, and it's going to have a few things in it. The first thing that we're going to need is we're going to need a position for the strike to start from. So we're going to call that, we're going to have a p vector called start, and then we're also going to need a few more variables, but I'll get into that in a second. So we're just going to have our store a p vector here called start, and we're just going to say this dot start equals start. So the way I was thinking of doing this was going to draw, have the start set, and then draw a line that slowly gets longer, and then once it reaches a random height it'll create a new line that goes off at a random direction relative to it. So, and it could even create two more lines, so then each line will fork off and it'll look like lightning. So we're going to do that somehow. So we're going to figure it out. So we want to have an update function, and we're going to have a show function. So we'll go void update and then void show. So one way we could do this is we could use polar coordinates. So we have the start position, and then we'll go off at a certain angle, and we'll just increase the radius that it's drawing at each time. So that should be fairly simple. We'll do this, we'll create a float A, which is the angle, and then we'll also create the radius. So what we could do is we could get the radius, the maximum radius in here. So we'll say float, we'll call it h for height. So we'll say float h, and then in here we'll say this dot h equals h, and then here we'll just leave the angle and the radius blank for the moment, and we'll randomly create them when we make the strike object. So we'll say a equals, so we'll say random I guess if we want it to be a random variable between like like 45 degrees these ways. So what's that? It's like pi on 4, and then also 3 times pi on 4. So that should be like here and here. So it'll randomly strike off in that direction, and then actually r will be set to 0. So then in the update function we want to, so we'll give it a speed that we're updating at. So then we'll say r plus equals speed. So the radius that we're drawing at is going to get bigger each time. And then that's all we need in the update for the moment. And then in show we're going to say have a line from start.x, start.y, and we're going to go to start.x plus cos a times r, and then start.y plus sine of a times r. So what that's doing is it's translating from that angle and radius into an x and y coordinate. So now if we create, if we say strike s equals new, actually no, I'll initialize it in the setup so that we can use the width and height variable. So s equals new strike. I just realized that I used a little s, not a big S. New strike, and it's going to be at new p vector that's width on 2, height on 2, like that. And then what other variables do we need? H, the height. So we'll say that that's 10 for the moment because we haven't actually done anything with it. And then we'll say s dot update. We need to give it a speed, so I'll say 1 for the moment, just to see if it works. So now when we run this, we should see a line that goes out at a random angle and slowly gets bigger. So if we run this, we should see that we don't get anything, and that's because we haven't called s.show. So now when we run it, we should see that we get a line that gets bigger over time. And it looks a bit weird, and I think that's because the background isn't being cleared each time. So I'll say background, and we'll use the same, we'll use 150 because it's a nice light greyish colour. And so there, we get a nice line that grows and grows and grows, and that's just going to grow infinitely at the moment. But since we've given it this height thing, what we can do is in the update function, see if r is greater than the height. So we only want to update this if r is less than h. Otherwise, we don't want to increase it, and it's actually, we'll need to spawn it a new segment of the strike, the lightning strike. So what we might want to do is we're going to, up here, we're going to say, we want to set the number of strike lines that we can have, and then also what number we're up to. So the way we're going to do that is we're going to have int n and int max. So n is the number we're up to, and max is the number that we want. So I'll do that in here in the initializer. So this dot n equals n, and this dot max equals max. And so now when we create the strike, I'm going to have to add a few more things in. So the first one, n, it's the 0th one, and we'll say that we want, I don't know, 5 of them in total. So that means we'll get 5 segments all up. Okay, so what we're going to do is we'll need a p vector for the end of the lightning strike, because that's where the next one will start, and we'll need to feed that into the new strike object. So that can be left blank at the moment. Actually, I can do it like this, save the line. And we're also going to, we're going to limit it to only having a left and a right split, but we're going to, we need to check if we've already created them or not. So we're going to have some booleans for that. So we'll go boolean, we'll need to check if we've split already, and then we'll need to check if we've got the left or the right one, which will be up to a random chance. So split equals false, boolean left equals false, and then boolean right equals false. So these will come into play in just a second. Alright, so and actually what we might want to do is, instead of having h a fixed value so that they're all the same length, we could make it so that it's a random length that's near that value. So we could say this dot h equals random 10 plus h. So it's always going to be around h, but it could be longer or shorter. Actually, we could might make it a bit more dependent on the variable, so have it h on 2 like that. And then we can calculate this end value right at the start. So we can say, because once we know the angle, we can just get the total h value, and then once it gets past that, we can calculate where the end is. So end equals new p vector, and it's going to be at what is it, start.x plus, actually we can probably copy these ones. So I'm going to say start, and instead of times r, it'll be times h, because that is the maximum value for the radius. So now when we run this, we should see that it's capped at a length, and it's really short because I think we've set h to be really short. So I'll say 100, and now it should, yeah, so we get a fixed line size, and we should be able to see that it goes at different angles. Yeah, so that's good. So now once it gets here, so if it's greater than or equal to h, we need to check if we've already split or not. So we're also going to need some strike objects for the left and the right. So we're going to have strike S1 and S2. So now, if it is bigger, if the radius is bigger than the height that we want it to be, then we need to split them, but we need to check if we've already split them or not, because this is going to be updating every frame. So if we haven't split, then we're going to create new strike objects, and then if we have split, then we need to update those strike objects every time the parent one is updated. So if it hasn't split, we're going to randomly choose if we get a left and a right or not, or if we only get one. So to do that, I'm going to say if random 1 is greater than 0.5, we'll get 2 of them. And so we'll say left equals true, right equals true, and we'll say S1 equals new strike, and it's going to have a start position that's the end of this one. It's going to have a float. Ooh. Okay, so we've stored this h variable with a random component on it, so it's going to be changing every time, and I don't think we want that. So I'm going to say, I'm going to create another float and call it d, and that will store the random one. So I need to change all of these to be d's, and this one, and then h will store the original value. So then we can just say h here, and then so then the number that we're up to will be n plus 1, because this is in the generation after, and then the maximum will still be the maximum. So we need to check actually that we're not at the maximum, and I'll do that in a second. So once we've already created however many levels of strike we want, we don't want to keep creating more. So to do that, in this checking if it's already been split or not, we also want to check that we're not at the bottom level of the strike. So if not split and n is less than max, so that should make sure that if we've gone too many, we won't create any more strikes. So we've got a 50% chance of creating 2 strikes, like forking it, or we've got a 50% chance of only creating 1 more. So we've dealt with 2 of them, and so if it's less, then I keep forgetting that I've used the lowercase. If it's less than 0.5, then we only want to create 1 strike. I could just use 1 boolean, couldn't I? I think so, yeah. So I'll just say, I'll call this both, like that, and I can get rid of one of these. So I'll say both equals true or both equals false, and then S1 will be the same. Okay, so if it's not split and it's less than the maximum, it will create a split, and so I'll need to make split equals true so it doesn't happen again. And then if it's already been split, then we need to say if both, then we need to do s2.update and show. Actually, I'll do that in the show function. So if it's both, we need s2.update, and we'll always update s.1 because we're always going to have at least s.1, and it needs a speed, so I'll put in the speed variable here, like that. So that should make it so that when we get to the end, once the strike has gone to its maximum height, we should see that we create more lightning, hopefully. So when we run this, it'll go down, get to its height, and then it's not doing anything. So let me let me figure out why that's happening. Oh, I see what's wrong. So these update functions should actually be not there. So we want to say, we want to get these out of here and put them just in here. So we want to say if split, then we'll do that. Otherwise, we're not going to. Okay, so before it was only going to update them if it wasn't already split. So hopefully now it should work when we run this. We should see that it splits off. It still doesn't split. What have I done? Obviously. Okay, so we're not actually calling S1 or S2.show. So they're not going to show up if if they're not being called in the show function. So I'm going to copy this thing and paste it into the into here, into the show function, and we're going to say show. I'm a silly sausage, and we don't need the speed. So now when we run this, we should see them on the screen. So they're gonna, yep, we get a split, and they only got 1 split each. So we can see that it's splitting and it's working. I might just here move this up to the top of the screen. Actually, I'll keep it width on 2, and then say like 100. Okay, so now we should see that we get them, get split, got a 2-way split. That one got 2 as well. Whoa. Okay, so you can see that it's kind of resembling a lightning strike now, but this is just going to keep going on forever because, oh well, it's not going to go on forever, but it's not going to die out because we haven't checked to see if we've hit the bottom level and we've finished the bottom level. So if in this update function we need to check if it's the last level and if it's hit the bottom, like if the size is greater than the size we need it to be. So we're going to create a new boolean called dead, which is going to be false. And so then dead equals false. So then in this update function we need to check if it's died. So if n is less than max, it's not going to be dead because it's still not the bottom level. But if n is greater than or equal to max, oh, completely forgot the if statement. So if n is greater than or equal to max, then we want dead to equal true. Okay, so oh, I've put that in completely the wrong spot. So I'm going to copy that out of there. That was meant to go down here. So if it's not split and n is less than max, it'll split. But if it's n is greater than max, then it'll become dead. And otherwise, we need to check if both of its, if it's already split, then we need to check that its children, if its children are dead or not. Sounds pretty morbid, hey? So if both, then dead equals s1 dot dead and s2 dot dead. Otherwise, we need to check dead equals s1 dot dead. And actually I'll need to put that in an else. So now running this won't actually have changed anything because we're not doing anything once it is dead. But like a simple thing we could do is in this show function, just check if it's dead or not. But I think it would be better to sort of have a controller for this in the just the processing sketch. So instead of having just one lightning strike, what we're going to do is we're going to have an array list of them. So array list strike s equals new array list strike, like that. And then we're going to get rid of that, and we're going to add one every time we press the mouse button. Okay, so we're going to say, or every time we release it. So void mouse released, and we'll go s.add new strike. And it's going to be it's going to have a new p vector as mouse x and mouse y. And then what other variables does it have? It's got how long we want it and the numbers. So h will say 50, and then 0, and we'll give it 5 levels. So we should be creating a new lightning strike every time we click the button, and then we need a loop to go through and update them all. So we'll say for int I equals 0, I is less than s dot size, I plus plus, and then we'll say s dot get I dot update, and we'll give it a speed of 10, and then s dot get I dot show, and then we can say if s dot get I dot dead, so we're going to check if it's dead, then s dot remove I. And actually, this isn't going to work because, well, it'll kind of work because we're going through the array forwards, but every time we delete one, the list is getting shorter, and so eventually we'll get an array out of bounds index, out of bounds error. So the way to fix this is if we go through the array backwards, all the ones we're deleting won't be affecting our position because we're getting towards the start instead of towards the end where they're getting removed from. So we can say int I equals s dot size minus 1, oh, we got the brackets, minus 1, and then we'll go until I is greater than or equal to 0, because we want to include 0, and we'll say I minus minus. Oh, I forgot little brackets up there. So now when we run this, I get an error because I haven't put in enough brackets. So now, once I fix that and we run it now, we should see every time I click the mouse, I get a new lightning strike. And now you can see that there's a bit of an error going on with, it looks like the, it's kind of hard to see, but some of the strikes seem to be going past where its children are coming out from, and so there's a weird like overlappy thing going on. And I think the reason is because we're adding, what's our speed set to? 10 every update to the radius that we're drawing. If it goes past it, like it can easily go past that before it gets checked to see if it's bigger than the radius that we want. So we can just simply say, so if r is less than d, then we keep adding the speed, but otherwise we want r to equal d, and so that should mean that even if it goes past, we're going to reset it to the maximum that it should be. So now when we run this and we click, we should see, yeah, we get nice clean lines, and you can see we can add multiple lightning things. So I think one thing that would be cool to do to this would be to change the thickness of the line as it gets closer and closer to its maximum size, so that it looks like it's expanding out of the air. So the way to do this, I think, would be, so we'll set the stroke color first. We'll make it yellow, which I think is like that in the RGB, and then we'll set the stroke weight to be, an easy way to do this without using the map function is just to use, what's it called, just a fraction. So we'll say r divided by d, so r is the current radius and d is the maximum radius size, so that'll give us a value between 0 and 1, and then we just times it by whatever we want the maximum to be, so like 5. Oh. So now if the radius is 0, then we'll get a stroke rate of 0, and if the r is at its maximum, we'll get a stroke rate of 5. So now when we run this, we should see that when we click, the lines get thicker, which is kind of hard to tell, to be honest. So I might, maybe if I make them a bit thicker at their maximum, and maybe also if I make them longer and slower, maybe it'll become more obvious. But so when I click, yeah, you can really see it now that they get thicker as the lightning grows. So yeah, that's a lightning effect. I think it's moving a bit slowly to be properly lightning, so if I make it 20, and I might make them a bit thinner because they were a bit fat for lightning strikes, but there you go, we've got some lightning strikes in processing. So thanks for watching. I hope you enjoyed this challenge. If you did, and you want to, be sure to subscribe. Otherwise, in the description there'll be a few links. I've got the GitHub with the code for this this coding challenge, as well as a link to the processing website where you can download processing, get started with all this. It's a lot of fun. There'll also be a link to my website, and on there you can vote for topics for the next coding challenges and also submit your own ideas if you've got them. So yeah, be sure to check that out. Cheers for watching.